Good day, students. Welcome to our economics class. My name remains Mr. Emmanuel. In this session, we will be treating the measures of dispersion. Measure of dispersion, it's a measure of testing how the variables in a data set vary around the mean. It is also known as measure of spread or measure of variation. The four types of measure of dispersion we'll be treating in this session include the range, the mean deviation, the variance, and the standard deviation. So let's start with range. Range is the difference between the highest number in a data set and the lowest number in the data set. Quite easy. Let's look at this example. Given this set of data, we are asked to look for the range. So first, we try to identify the biggest number in this data set. So the largest number here, can you see it? It's 74. While the smallest number is 23. So our range for this data set is 74 minus 23, which gives us 51. So our range is 51 kg. Quite easy. Next is the mean deviation. The mean deviation measures how the observations in a data set vary around the arithmetic mean. The formula for calculating the mean deviation is summation f open brackets x minus x bar, which is the mean, close the bracket, divided by summation f. Now let's look at this example. Using the same data set we used for range, let's prepare the mean deviation. So the first step to make it easy is to group our data. So we choose the class interval 21 to 30, 31 to 40, 41 to 50, and so on. When that is done, we use our knowledge of tally to assign frequencies to them. So we look at the data. What numbers fall within 21 to 30? You count them and put the frequency. So for the first one, 2. You look at the second class. What numbers fall within 31 to 40? So using that system, we populate our frequency column. The next step is to get the midpoint. The midpoint is the sum of both class intervals divided by 2. So for the first class, we would have 21 plus 30 divided by 2. For the second, we would have 31 plus 40 divided by 2. Clear? Then we multiply the frequencies times the midpoints, and that gives us fx. When this is done, we add up all our fx and all the frequency. Then we can now calculate our mean by doing summation fx divided by summation f. And this is 2535 divided by 50, which is equal to 50.7. When this is done, we can now add an additional column of doing x minus x bar, which is our mean. So for each of our x, we subtract it from our x bar. So for the first, we'll do 25.2 minus 50.7. you would observe that it's inside something that looks like a bracket. What that means is that we are taking the absolute value of the mean deviation. That is, whatever our answers is, we take away the sign, whether it's minus or plus. When this is done, we'll multiply our frequency by our x minus x bar. Then we add up all our f in brackets x minus x bar. I believe that is clear. So finally, we divide our summation f into brackets x minus x bar divided by summation f. So that gives us 529.6 divided by 50, which gives us 10.59. I believe you understand these processes. Next, we move to our variance. Variance is the average of the squared mean deviation of each observation in a data set. In calculating our variance, we get the squared of the mean deviation before we find the average. The formula for this is summation f into brackets x minus x bar, close the brackets, square raised to power 2 divided by summation f. So let's treat this example. Using the same data set that we have, we are just going to add two more columns. The first is immediately after our mean deviation, that is x minus x bar. We are going to square all our results. So from the first one, we do 15.2 times 15.2 or 15.2 raised to power 2. You get the same thing. So you do that for all the observations we have under x minus x bar. When this is done, you multiply your results by the frequencies. That gives us f into bracket x minus x bar squared. When this is done, we would add up what we have as f into bracket x minus x bar, so that we have summation f into bracket x minus x bar. Then we divide it by summation f, and that gives us 7,898 divided by 50. And so our variance is 125.9. Finally, we move on to standard deviation. Standard deviation is simply the square root of your variance. Simply put, the square root of your variance. So to solve our variance using our example, we just look for the square root of 156.9. So try square root of 156.9, and that gives us 12.53 kg. Rather simple. Thank you for your attention in this class. I believe at the end of this class, you understand what measure of dispersion is and the 4 measures of measuring dispersion. See you all in the next class. Bye.